Now guys, let's see a property which is related to inequality, but we can say that the roots, the basic can be proved by logarithms also, although it can be proved using graphs also. So this is a topic of inequality and logarithms both. We call it exponent inequality, guys. So the rule states like this, guys, that a to the power x 8 is greater than a to the power y, then x is greater than y. Means if the exponent, the power, the base a is same here both sides, we can remove the base and we can directly relate the powers without changing the sign of the inequality, provided the base, the exponent is greater than 1. Okay. So what are x and y here? What are x and y? So guys, x and y here can be, are they positive or they can be any real value? So the thing is, guys, x and y can be any real value, guys. Why? Because x and y are in the power of a. There is no log, or they are not in argument of any logarithm. That's why x and y are real numbers. So this is the first part of this result. X is greater than. Second part is, we can write this as x less than y. Here we have to change the sign. Okay. In the case when a is between 0 to 1. So in that case, if you are removing a, then x and y are related by the opposite sign of the inequality. See here, initially it was greater. Now as you can see here, it is less than here. Okay. So this is the basic inequality, logarithmic inequality or exponent inequality result. Okay. So what is the proof of this? I would like to explain it once again. So what it states, once again I will say that if suppose if a to the power x is greater than a to the power y, then you remove a and x is greater than y. If suppose here it is greater than equal to, then here also it would be greater than equal to. Okay. So this is possible. This is true when the base is what, guys? When the base is greater than 1, guys. This is the first part. And the second part, it states that if a to the power x is greater than a to the power y, then x is less than y. The sign gets changed when the base is what, guys? When the base is between 0 and 1. And it acts both ways. Like if a to the power x is greater than a to the power y, then x is less than y, base is 0 to 1. Or it can be understood both ways, in the reverse way also. Like if x is less than y, then a to the power x is greater than a to the power y also can be used if base is between 0 and 1. And the similar way we can say about the first part also. Okay, both ways it is valid, where x and y are what? X and y are real numbers. Okay, so this is the exponent inequality. Now how we can establish that? The proof is, we know from logarithms that m greater than n, log m is greater than log n base a, provided a is greater than 1. So we will prove the first part of this inequality. Okay, a to the power x greater than a to the power y implies x is greater than, the first part we will prove. In the similar way, the second part can also be proved, guys. Okay, so what we will do now, using this fact that we have done from logarithms, let's assume that m is equal to a to the power x and n is a to the power y, guys. That we will substitute here in place of m and n. M greater than n is now replaced by a to the power x greater than a to the power y here, and similarly this part here also it is replaced by m and are replaced by a to the power x and a to the power y respectively, guys. Okay, so now as you can see, this x we can take in multiplication using the property. Y also can be taken in multiplication. Y comes down in multiplication using the property log m to the power n is equal to n log m. Okay, so now log a base a is 1. Okay, so it becomes in the next step what, guys? In the next step it becomes this x greater than y. So you can directly relate now to this a to the power x greater than a to the power y means x is greater than y. So that way it is proved for which a, for a greater than 1. Okay, so for in the similar way we can establish for a lesser than 1 using the same logarithmic inequality. This one we can use for a, instead of a greater than 1 we can use for a between 0 to 1. So the second part can be proved for x less than y when the sign changes. That can be proved by taking a0 to 1, the same logarithmic inequality. So now let's see some example on this. Now if 3 to the power x minus 2 is greater than equal to 3 to the power 2x minus 3, what is the value of x, guys? So we can, as you can see here, this is some kind of a to the power x greater than equal to a to the power y. Since a is 3 which is greater than 1, so we can remove a. So directly the powers are associated are by this in sign of inequality, so directly we can use this x minus 2 is greater than equal to 2x minus 3. As you can see here, sign isn't changed because the power is greater than 1. So taking 2x on left hand side minus 2 on right hand side, so this becomes minus x greater than minus 1, multiplying by minus 1, sign gets reversed, x less than 1 is the answer. Now let's take another example, guys, which is this 2 by root 3 power x square less than power 49. So as you can see here, 2 by root 23 is what, greater than 1 or lesser than 1? So yes, it is between 0 to 1. So if I remove 2 by root 3, x square and 49 would be related by which sign? So yes, they would be related by, they would be connected by the opposite sign, less than. Instead of less than, we will put x is greater than. So x is 49 is 7 square, and using this formula we will write this as x greater than 7 or x less than minus 7. It can be written in terms of interval form also. Similarly, in the next 1 less than equal to 7 to the power minus x plus 5 less than 49, we have to find x. So what should be the approach? So clearly we try to find, the hint would be to express in the power of 7, here also in the power of 7, so that 7 is removed and the powers are associated by the same sign because it is greater than 1. So the same thing we did in the next step in the solution. 1 is 7 to the power 0, 49 is 7 square, and now in the next step they are associated by the same sign here as well as here. Okay, now adding minus 5, okay, both sides, this cancels out, okay, and this becomes minus 3. Now multiplying by minus 1, x sign is reversed and it comes between 3 and 5. Okay, now in the next example the question is 1 by 5 3x minus 2 greater than 0.008 to the power 11. If x is natural, find number of solutions. So we have to find number of natural number solutions which satisfies this inequality, guys. Okay, so clearly if this is 1 by 5, the hint should be this is 0.008 is to find a relation between 1 by 5 and 0.008. So what is the relation? If you think closely, 0.008 is nothing but what, guys? It is 0.2 cube. 0.2 is 1 by 5, so it is 1 by 5 whole cube. So 0.008 here in the question would be replaced by 1 by 5 whole cube, and then this becomes 33. Now 1 by 5 is common as the base. So if you remove 1 by 5, the sign would be reversed from greater to less than, because 1 by 5 is fraction, positive. Now adding 2 both sides, this becomes 35. Dividing by 3, this is written like this: 33, 11, 2 by 3 in mixed fraction. So since x is a natural number, 1 to 11 will satisfy this. So obviously number of solutions are how many? Yes, there are 11 solutions. Next is 25 to the power x minus 30 into 5 to the power x plus 125 less than equal to 0. We have to find x. So as you can see, observe the hint would be, as you can observe here 25 to the power x is given. Here 5 to the power x, it means 25 to the power x is 5 square, which is 5x power 2. So if you replace 5x by t, you will get a quadratic in t, because one more second term is in 5 to the power x. So that quadratic inequality, if you solve using wavy curve and get the answer. So this question, if you put 5 to the power x as t, okay, like this, it is written 25 to the power x is written like this. Other steps are as it is. So 5 to the power x is replaced by t and t here. Now what is t? Is it t positive or negative? So a to the power x, if a is positive, x is any real number, t is always positive. Okay. Any number you can take as an example to verify, although from the graphical graph of a to the power x it can be easily proved, but if you take any positive number and put any positive or negative power, you will get a positive number only. So t is positive. So although this fact won't be used in this question, but just I asked. So t square, so this reduced to this quadratic, splitting the middle term 30t, and then first two term taking 2 t common and second minus 5 common, you will get t minus 25 out, t minus 5 less than equal to 0, which is quadratic inequality, whose two zeros are 5 and 25. Putting plus minus plus, the question is asking for less than equal to, so equal to, we will place a dark circle here, and plus minus plus, so we will take minus values, so t between 5 to t between 25, t greater than equal to 5 less than equal to 25, so t is again resubstituted as 5 to the power x, 5 is written like this, 25 like 5 square, so 5 is, since the base is greater than 1, sign won't be changed, we will remove 5, so x is between 1 to 2, both included, that's the answer. Now what about, let's take this question, now 13 to the power x plus 4 greater than 0, we have to find x. So how we can approach this? Now if you first approach, you try to take my 4 this side to minus 4. Can you express this in terms of 13 to the power something? Now as I said in the previous example, a to the power x is always a positive number irrespective of if a is positive. Okay. So this is positive, minus 4 is negative. So a to the power 13 to the power x is positive, minus 4 is negative, which is an identity. Okay. So any value of x you will put, it will satisfy. It can be justified without taking minus 4 on the right hand side. Directly we can say that since 13 to the power x is positive, we are adding 4 which is also positive. It will definitely give positive. So whatever x we put, it will always satisfy, means the solution to this question is what? Yes, all real. Okay. X belongs to minus infinity to plus infinity. Let's take this example now, guys. 16 power x minus 1 greater than equal to 7. Find x. So guys, now here 16. So again we will think of expressing 7 in terms of the power of 16, which constitutes the hint of the question, expressing 7 in terms of 16 to the power. Now how we can express 7 in the power of 16? So if you think closely, which rule can be used to express 7 in terms of 16 to the power? So that rule is this, guys. A to the power log x equals to x. So you can take a as 16 here. So it is like this, guys. Using the same rule in this question, 7 is expressed as 16 to the power log 7 base 16. As you can see, a is 16, x is 7 in this formula. Okay. Now directly using the formula, sign won't be changed, greater than, because the base is 16 greater than 1. X minus 1 is greater than log 7 base 16. So x is greater than 1 plus log 7 base 16, which is the answer. You can write it in interval form, 1 plus log 7 base 16 to infinity. What about this, guys? Now 8 to the power x minus 2 into 8 to the power x plus 5 greater than equal to 0. We have to find x. So here we have two factors. If we examine the two factors closely, that will give the way to approach further. That constitutes the hint of this question, guys. Like, what is the second factor? 8 to the power x plus 5. In the previous examples, we have seen a similar example. So we know that 8 to the power x is positive. This is positive. So this is positive always. Always positive, irrespective of x. So this factor is always positive. So what about the sign of this, so that the product of these two gives greater than equal to 0 or positive? So guys, the sign of this should be, it should be positive, because this is positive always. So positive into positive will give greater than equal to 0. Okay, greater than 0, equal to will equate also. So it means since this factor is always positive, this factor has to be positive so that their product is positive. So it means this factor has to be positive or equal to 0 so that the product is positive. So taking 2 on the right hand side and expressing 8 as 2 cube, so 2 to the power 1, so 2 since greater than 1, directly 3x is greater than equal to 1. Okay, since 2 is greater than 1, a greater than 1, so multiplying by 1 by 3, x is greater than 1 by 3 is the answer, guys. So guys, if let's say what is the value of log 4 base 2, we can write it as 4 as 2 square, and 2 will come in multiplication using log m to the power n is n log m. So log 2 base 2 we know is 1, so it is 2. Okay, so log 4 base 2 is 2. If I ask you what is the value of log 1 by 3 base 3, then 1 by 3 can be written as 1 by 3 power minus 1. Again, minus 1 will come in multiplication. Log 3 base 3 is 1, so it is minus 1. So as you can see from these two examples, and log a base a is, log 1 base a is 0 also. So the value of log x can be positive, can be negative, it can be 0 also. Okay, so in short we can say that we can also justify, prove by graphical, by using the graph of log. That is again a separate discussion, but we can say that log x base a, guys, can attain any big positive and big negative value. So we can say that the log x, it belongs to which set? So yes, we can say that it belongs to a set of all real numbers. Log x belongs to minus infinity to plus infinity, because the more you put x here, okay, the bigger the value of x you get when the base is greater than 1. That we can that we can bring more clarity and understanding when we use the log, which I said is a separate topic of discussion. As of now, log x is any real, but what I'm interested now is when log x to the base a is positive, guys. So when it is positive and when it is negative. So when it is positive is the first question. So what I mean to say is, for what value of x and a it is positive. So what we will do in order to find out, we will simply apply the constraint on log x base a. Log x base a is greater than 0. Now we will solve. So in order to solve, we need to take two cases: when a is greater than 1 and when a is between 0 to 1. Okay, when a is between 0 to 1. So like in this case, when a is greater than 1, if we have taken log x base a, since a is greater than 1, using the law of inequality, logarithmic inequality, a will come out and push a up, 0 up in the power, so it becomes a to the power 0, so x greater than 1. Similarly, if we, so we can say that when a is greater than 1, x is greater than 1, in that case log x base a is positive. In the similar way, if a is between 0 to 1, guys, so in that case, in the next step, we can write x a to the power 0, but the sign greater than sign would be replaced by less than sign. Again from the law of logarithmic inequality, so it becomes 1. But x is, we know x is a positive number, it is the argument, and x is x came out to be less than 1, but we know x is greater than 0. So x eventually is what, guys? X is also a positive fraction between 0 and 1. So in short, we have seen that if x is a positive fraction and a is also a positive fraction, log x is positive and a is greater than 1, x is greater than 1, in that case also log x is positive, base a is positive. So we can write it like this, that log x base a is positive when both are 1 greater than 1 or both are lesser than 1. Simple to understand, I think it is simple to learn, to remember it. It's not a big deal. And if I ask you what are the values, what are the signs of these? So as you can see here 7 is greater than 1, 3 is greater than 1, 3 and 7 again here are greater than 1. So we can say that they are positive. Here 2 by 3 and 1 by 5 both are lesser than 1 when between 0. So here also we can say that it is greater than 0. In the similar way, here if it is 1 by root 7, it is 1 by 2, it is positive. As I said, both should be fraction or both should be greater than 1. So the result is a positive result, positive value. Now what if, now if we choose the opposite, if a is chosen to be a fraction and x is chosen to be greater than 1 and vice versa, that is a is greater than 1 and x is between 0 to 1, in that case what is log x? So yes, in the similar way we can prove that in that case log x would be negative. So this also we can remember, right? So the examples are these. As you can see here greater than 1, here 0 to 1, here greater than 1, between 0 to 1, here between 0 to 1, here the base is greater than 1. So in all of these examples the value of log is negative, guys. Okay, and here as well, guys, here as well it is negative. So now let's take another example. If x is log 3 base 5 and y is log 5 base 3, which one is greater? X is greater than y or y is greater than x? As you can see here, 3 and 5, since both are in the both of these numbers are greater than 1, so obviously first we can say that x and y both are positive, but the question is more precise. They are asking which one is greater out of this. So the thing is, sometimes we can establish it like this. 3 and 5 are given, so we can establish an inequality using 5 and 3 like this. So we can start with this, 5 is greater than 3, so we can take log base 5 both sides, so the sign of inequality won't change, okay, using the law, because the base is greater than 1. So log 5 base 5 is 1, this is x, so we got 1 is greater than x or x is lesser than 1, this is first. In the same way, 5 greater than 3, again we will use, now we will take base as what? Logarithm with what base we will take? So yes, we will take base 3 now, okay, like this. So log 3 base 3 is 1 and log 5 base 3 is y. So y greater than 1 is second. So x came out to be lesser than 1, y came out to be greater than 1, x lesser than 1. So as you can see here, x is what? X is lesser than y. Okay. So how we can proceed with this question, where it is some kind of inequality in log x base 3 whole to the power 4 minus log x to the power 5 upon 9 is the argument, 1 by 3 is the base whole square, minus 20 log x base 3 plus 148 less than 0. We have to find x. So guys, since this is an inequality, what should be the approach? What should be the hint of this problem, guys? So as you can see in the first term here, it contains the base 3. Here the base is 1 by 3. So 1 by 3 base can be converted to 3. Here also the base is 3 only. So everything is in base 3, log x base 3, everything can be converted. So from first, what we saw that it was in log 3, the third term also was in log 3, which means that the second term also we should convert it in terms of log base 3. So when you convert it in terms of log base 3, the second term mainly, because second term needs some kind of, we need to solve it, okay. So if you solve the second term, you will, and the entire left hand side, you will get a quadratic in log x base 3 whole square, which is also, we can also write as log square x base 3. We all know that this is not equal to log x square base 3, because this becomes 2 log x base 3. So this will be converted into a quadratic t, where t is log x base 3. It means we will get an equation in fourth degree of log x, because if you are if this becomes, if the quadratic in t, it will contain term containing t square, so this becomes power 4, so and so on. So once you get a quadratic, you factorize it using whatever the using quadratic formula, or splitting the middle term, and after that we will use wavy curve method to solve it to get the value of x. So that would be our approach. That is the hint to this problem. Now moving on to the solution part. So as I said, the second term needs some simplification, some solving. So second term is what, guys? So it is this. So first what we will do, we will write this 1 by 3 as 3 to the power minus 1. Okay. So this we will write as 3 to the power minus 1, and this minus 1 will come down using this rule, log m base a to the power n. So n goes down in multiplication, 1 by n log m base n becomes, so this minus comes here, okay. So this minus 1 and this term, these two are separated, so this minus 1 square becomes 1, and this, now this term log x power 4 base 9, we can consider this as log m base n, so we can expand it as log m minus log n. So we can write this as log x5 base 3 minus log 9 base 3 using this formula. Whole square is as it is. Now this 5 here will go down here like this, using this log m to the power n is n log m. Similarly here also, this 9 we will write as 3 square, and 2 will come down, okay. So 5 log x base 3 minus log 3 square becomes minus 2 log 3 base 3, which is, we know log 3 base 3 is 1. So this only is, this is minus 2 only. So squaring using a minus b whole square, we'll get a square plus b square minus 2ab. This becomes log x base 3 whole square is log x base 3 whole square, which as I said is also log x base 3 whole square, okay. So this is the simplification of the second term, which is this, okay. So this whole thing equals this. Let's say this is first result. So now moving on to the, now substituting this one in the original question, which was this was the original question, that was the inequality that we need to solve. So substituting log x to the power 4, the second term log x 5 upon 9 base 1 by 3 as this, from 1. Rest of the terms, as you can see, this term, the first term, and the last term 148 is as it is. The second, this okay. So the third term and the fourth term minus 20 log x is also as it is. So now if we simplify, multiplying it by minus sign inside this term will become 25, minus 25 plus 4 becomes minus 4, minus 20 becomes plus 20, which gets cancelled with this term minus 20. So this and this cancels out. Okay, so now this minus 4 and 148, if we add, we get 144, and at the same time we assumed log x base 3 as whole square as t, so this becomes t square, guys. Okay, log x base 3 to the power 4. Similarly, log x base 3 whole square is t, minus 4 plus 148 is 144, so the quadratic is splitting the middle term, minus 16 minus 9, taking t common, minus 9, t minus 9, t minus 16 less than 0, using the wavy curve method, plus minus plus, we need minus, so the answer to this would be t between 9 to 16. So this is 9 to 16. Now t we will simplify, sorry, we will again substitute as log x base 3 whole square. Okay, so t we have substituted as this, and now 9 is written 3 square, 16, 4 square, so we can write it as log x. What is the value of log x? It is between 3 to 4, and log x base 3 is between one more range. How do we got from this to this? So we used a formula, if you remember, from inequality, which is this: if x square is between a square b square, then x is between a and b, or minus b to minus a. So this question mark would be replaced by what, guys? So the question mark would be replaced by minus b to minus a. So minus, this was a, 3 was a, 4 was b, so minus b means minus 4 to minus 3 it becomes. Now using the definition from here to here, 3 will come out and push 3 up, so this becomes 3 cube, again this becomes 3 to the power 4. So in the same way, this equation will give what? 3 will push, so it will become minus 4, here also minus 3, so which gives the solution of x as this, which is a positive solution, so that it take care of the domain, and which is the final answer, guys. Try to solve this question, guys. Log base x square 2 plus x is the argument, greater than equal to 1, we have to find x. How we can approach this? So clearly we have to take care of the domain. Domain contains two parts, one is argument, another is base. So argument, clearly we need to ensure that it should be positive, which makes x should be greater than minus 2. So base, now in order to solve further, we need to ensure that either base, which is x square, it should be greater than 1, or it should be between 0 and 1, that is x square should be between 0 and 1. So it you know, it pushes us to take what? To take two cases, first case, second case. Okay, we also need to ensure that x greater than minus 2 and x square greater than 1. If you take case 1, we have to take the intersection of this, and here also x greater than minus 2 and this. Now if you take case 1 and if you take case 2, whatever you solve, after solving the equation, first we will get the domain, which will be calculated after taking the intersection in each of the two cases, and then we will solve it. After solving it, we will take whatever we obtained, the intersection with the domain calculated in each of the cases that we assume, and the final answer would be what, guys? The final answer would be the union of the two cases. Okay, the final answer would be final answer case 1 union case 2. So first we will calculate, we will assume case 1 where the argument, where the base is assumed to be greater than 1, x square greater than 1 square gives x greater than 1, x less than 1 from minus 1 lesser than minus 1, from the formula x greater than a square gives x greater than a or x less than minus a. So here in the second part, x less than minus, we have to take intersection with what? So intersection with x greater than minus 2. Okay, that is the argument part. So if you take intersection with minus 2, since this is guys less than minus 1 and this is minus 2 greater, so if you take intersection, this would be minus 2 to minus 1, and x greater than 1 is what, guys? It will satisfy greater than minus 1. Okay, greater than minus 2. So this is first. So this is what? This is the domain of the equation that we are going to solve next. So this is the equation, and in the next step x square will come and it will push 1 without changing the sign of the inequality, because of this fact log m base n, m is greater than a to the power n if n is the base is greater than 1. So taking x plus 2 on left hand side and then factorizing it like this, so x minus 2 comes out, x plus 1 also comes out. Wavy curve method, this is less than equal to 0, so plus minus plus, we will take the minus part, which is minus 1 to plus 2, and now we will take what? We will take intersection with the domain which was minus 2 to, which was this domain needs to be taken into consideration. So this we will plot here, my x greater than 1, this one, x greater than 1, x between minus 2 to minus 1. So if you take intersection with this, okay, so as you can see here, this portion 1 to 2, this is common to both here as well as here. So the intersection here 2 is also included, 2 is included here as well, 1 is not here, 1 is here, so their intersection would be 1 excluded, 2 included. So first case answer is this. So we need to, in the similar way, we need to solve second case, and we will take the union of first and the second case. So second case, now the base should be what, guys? Assume to be, yes, we will assume the base to be 0 to 1, that is x square between 0 to 1. Okay, so x square, we can write it x square less than 1 square, but here it should be understood that it shouldn't be equal to 0. So here this question mark, it means 0 should be excluded. X square less than 1 square, we know from inequality it is from minus 1 to 1. So 0 we need to exclude from minus 1 to 1. Now that in order to find the equation, the domain of the equation, we need to take its intersection with x greater than minus 2, that is the argument part. So if you take greater than minus 2, obviously as you can see here, minus 1 to 1 is all the values lying are between minus 1 to 1, they are subset of greater than minus 2. So the domain is minus 1 to 1 only, excluding 0. Okay, so this is the domain of the equation. Okay, let's say this is equation 3. Now whatever we obtain after solving this, okay, that we will need to take intersection with this equation 3. So in the next step, this to this x square will come and push 1 above. It will change the sign. Why? Because the base in this case is, since 0 to 1, the sign will change, the sign will be reversed. So now 2 plus x we will take on the left hand side as usual, taking factorizing, we will get the same factors, minus 1 and 2, plus minus plus, since this is greater than sign here, so we will take this and this as the solution of this inequality. We need to take intersection with third, which was what, minus 1 to 1 excluding 0. So minus 1 to 1 we need to take intersection with minus 1 to 1, guys. Okay, so what we will get in this case, guys, we will get, so taking intersection, as you can see here, minus infinity to minus 1, nothing is here. Now here minus 1 to 1, nothing is here. 2 to infinity here, but here there is nothing. So the intersection is what, guys? So yes, guys, intersection in this case is 5, second case. So taking union, first union second, first we obtained was this union, the second that we obtained is 5. So the final answer is what, guys? The final answer to this is 1 to 2, 2 included, guys. Let's see a question, guys. The number of integral solutions of log base x plus 7 by 2 x minus 7 upon 2x minus 3 whole square is the argument greater than equal to 0 is mains 23. Number of integral solutions, the meaning of this question is we have to find number of solutions which are integers which satisfies this given logarithmic inequality. Okay, so how should be the approach, what should be the hint to this problem, guys? So as you can see, this question is formulated like this: log a base b is greater than equal to 0. In order to solve it further, since base is b, which is a function of x, which is x plus 7 by 2, there can be two possibilities, that a is greater than equal to b to the power 0, or a is less than equal to b to the power 0 if we solve it further in the next step, depending on what is b. So in this case, let's say this is case 1, b should be greater than 1. So in the second case, okay, this is, if this is case 1, then the case 2, b should be what, guys? Yes, b should be between 0 to 1. So depending on what the base is, we have to solve. So it means we have to take what, guys? We have to take two case 1 and case 2, and then we have to take what, after solving the two cases, and we will get number of solutions in each cases. We have to add number of solutions. Okay, so we have to add number of solutions of each case 1 and case 2. Now for each case 1, how do we find number of solutions? See, the number of solutions, if you solve b greater than 1, let's say this is first inequality that you get, and then if you, following that, if you solve the second inequality, okay, so you will have to take in each case the intersection of first and second, okay, because both must be valid, both must hold. So in that case, after solving first and second, after the solving first and second equation, we have to take intersection, and we will, from that we can get number of solutions, integral solutions. In the similar way, guys, what we will do, we will solve this equation and this as well, and from these two equations, whatever we will get, we will take the intersection. And after solving, after getting number of solutions in each case, case 1 and case 2, we need to add, we need to plus the number of solution in each case. That should be our strategy. That is the hint approach to this problem, guys. So now let's move on to the solution. Case 1, and before that we need to take care of the domain. Okay, domain means what? The argument must be positive. Okay, domain must be, argument must be positive, since here it is square. So only thing that we need to ensure that the denominator, which is 2x minus 3, it shouldn't be 0, which gives us the domain of the argument as x shouldn't be 3 by 2. As far as this base is concerned, this should be positive, not equal to 1, will already be taken care if we take two cases, like if you take greater than 1 in case 1, or if you take between 0 and 1 in case 2, the argument of the base will automatically be satisfied. So the from the domain we need to take care that x shouldn't be equal to 3 by 2. Now we will solve the two cases. Case 1, when the base b, okay, should be greater than 1. So 1 minus 7 by 2 minus 5 by 2, which is x greater than minus 2.5. This is the first constraint. Now the second one will be solved by solving this. So the next, x plus 7 by 2 to the power 0, converting using the log inequality. Okay, the base will come, push this 0 up. Okay, so this, what would be the sign? The question mark would be replaced by, since we already assumed the base to be greater than 1, this would be replaced, this would be the same as this sign, so it has to be greater than equal to. So x plus 7 by 2 is what? To the power 0 is what, guys? It is 1 only, and we can split this as separate squares in numerator and denominator, cross multiplying this here, and then transposing it on the right hand side, x minus 7 whole square, using a square minus b square gives you a minus b, a plus b. So 2x minus x, okay, so 2x plus x will give you 3x minus 3 minus minus 10. So this was greater than equal to 0, 0 greater than equal to, so here it would be less than equal to 0. Okay, we simply interchanged it. Okay, because these two inequalities, they are same, guys. These two way of writing is same. So 3x minus x, so 3x minus 2x minus x is x, minus 3 plus 7 is 4. This is as it is. Now this we will use wavy curve method, quadratic inequality. The two zeros are minus 4 and 10 by 3, which is approx 3.34. So we will plot them on the number line, and then we will use plus minus plus. Now since here it is less than equal to 0, so minus sign solution we will take. So we will take, guys, this from 4 to 3.34 we will take, guys. Okay, now from this is the second equation that we got. Okay, the first that we got was from the domain, which was from what, guys? It was from 2.5 to infinity, minus 2.5 to infinity, which I have plotted it here. Okay, the first equation, it was from the first equation from domain, it was x greater than minus 2.5. So now as you can see here, the common areas of both the inequality start from minus 2.5 till 3.34. As you can see from both the inequality, this is the overlap region which gives the common solution from minus 2.5 to 3.34. Now if you see the integers from minus 2.5 greater than this, it would be, first integer would be minus 2, then comes minus 1, then comes 0, then comes 1, then comes 2, followed by 3. So as you can see here, if you count minus 2, minus 1, 0, 1, 2, 3, number of integral solutions from 1 and 2 intersections comes out to be 6 values from case 1. Now case 2 we will solve when we'll assume the base to be what, guys? Yes, when in that case we will assume the base to be between 0 and 1. Subtracting minus 7 by 2 both sides, we will get base as minus 7 by 2, that is minus 3.5 to minus 2.5. Okay, this is another, this is the first equation from case 2, guys. Okay, now uh, since in the previous, in case first, when we solved for greater than when we assumed x plus 7 by 2, uh, which was greater than 1. Okay, so we got the answer to be this. So in the second case, if you take the base x plus 7 by 2 here to be between 0 and 1, in that case the sign of the inequality would be reverse. Okay, so the answer would be r minus whatever we got in this. Okay, but minus 4 3.34 would be the common solution. So if you got from case 1, if you got case 1 this, so remaining solution from the number line case 2, it would be like this, guys, from minus infinity to minus 4 and 3.34 to infinity. Now here equation 1, from equation 1, that is the what we assumed, the base constraint 0 to 1, this 1 would be written here, guys. This is 1 minus 3.5 to 2.5. Now if you take the intersection, there is no common points here in this minus this solution. Okay, so if you take intersection, nothing we will get, no values of x, we will get 5, no values of x from the intersection of first and the second. Second was obtained by solving the same logarithmic equation. Okay, so no values of x. So in case 2, number of values of x that we got is 0 in second case. So final solution, number of values of integral values, we will add number of values that we obtained from case 1, which was 6 solutions, case 2 which came out to be 0. So eventually it is the number of solutions that we got from both the cases came out to be 6. So guys, if we try this question, which is log base is mod x minus 1, argument is x plus 2 whole square greater than equal to 0, we have to find range of x. How we can proceed with this, guys? So if you, first of all, if x in log is involved, whether in equation or in inequation, we have to take care of, we have to check for the domain. And base also is, if a base is also a function of x, then in order to solve the inequality, what we have to do? So if you can recall, if base is also a function of x, then we have to take two cases, guys. In first case, we have to assume base to be greater than 1. In the second case, base has to be what, guys? Yes, in second case, it has to be assumed to be between 0 and, so that we can solve it further. Okay, and we also have to check the domain. We have to ensure that x plus 2 whole square is positive. Since it is square, it is already positive. So it needs not to be 0. That we need to ensure, guys. Okay, so what is the final answer, guys? So first case we will solve. Okay, base greater than 1 we will solve, and we will also use this fact x plus 2 whole square, it should be greater than 0. So clearly x shouldn't be equal to minus 2, and otherwise any value will do. So whatever the value that we get after solving base greater than 1, that we have to take intersection. Same we have to do here as well. X not equal to 2 and base 0 to 1. And after the solving the two cases, how do we obtain the final answer, guys? So after solving the two cases like this, the final answer, it has to be what? It has to be the union of case first and the second. Okay. So starting with the domain of this logarithmic left hand side term, we need to ensure that x plus 2 whole square, that the argument should be greater than 0. Okay, it shouldn't be equal to 0. So therefore x plus 2 shouldn't be 0, which gives the domain of the argument to be not equal to minus 2. We can also go for solving the domain of this, but since we are already taking two cases, that argument the base is greater than 1 or less than 1, so for this domain calculation is not required separately. When we take the cases, automatically it will take care of the domain. So if you take the base to be greater than 1, the domain would already be taken care of. Okay, so we only need to solve the base should be greater than 1, where the base is this. So mod x greater than 2, mod x greater than a, we know it is x greater than a or x less than minus a. Let's say this is second. So what was the first? This was the first, guys, that x shouldn't be minus 2. So first intersection second is what, guys? As you can see here, x already is not there, x equals to minus 2 is already not there. So in this case, this question mark, we can say that this is 2 only. So this is 2, 1 intersection 2 is 2 only. So what we obtained in the first case is this only, guys. Okay, that is the domain. Now we will solve it, guys. Okay, now when we solve it, this mod x minus 1, it will push this 0 up using this rule of inequality log m base n, where n pushes a up without changing the sign if n is assumed to be greater than 1, where we already did. So x plus 2 whole square, expanding this is 1, this is 1, 1 goes left hand side. So this quadratic splitting the middle term and factorizing x plus 3, x plus 1 also comes out greater than equal to 0. So using wavy curve method, x plus 3 equals to 0 at minus 3 and minus 1 respectively. Using wavy curve plus minus plus, we want plus, so this would be this. Okay, and let's say this is third. Okay, now the domain which was second, okay, the domain was 2, which was minus infinity to minus 2 and 2 to infinity. So if you take the common points of intersection, their intersection, which is this, it has to be minus infinity to minus 3, and here also it has to be 2 to infinity, here also 2 to infinity. So first third intersection second, which is the answer of the case 1, is minus infinity to minus 3 union 2 to infinity, guys. Okay, this is case 1. Now we will solve case 2, when the base is what? When the base is between 0 and 1, adding 1 both sides, it becomes 1 and 2. So what is x, guys? So we know the result, mod x a to b, x a to b union x minus b to minus a. So it will be 1 to 2, or that is the union x minus 2 to minus 1. Okay, this is the second case, this is the domain of the second case. Okay, let's say this is 4. So now we will solve this equation. So x minus 1 mod x minus 1 will go and will push 0 up. The sign from greater than would be reversed. Why? Because the base is 0 to 1, so sign reverse from greater than to less than. Okay, so again the calculation is same as in case 1, so I won't write all these steps. Eventually we will land up to this step only using wavy curve method. It would be minus infinity to minus 3 plus minus plus, sorry, it would be minus 3 to minus 1, guys, since minus is there, and these two are included, minus infinity, minus 3, minus 1. So if you take intersection with our domain, which was what? It was minus 1 to 2. The domain is 1 to 2 and minus 2 to minus 1. That we will plot here. Minus 2 to minus 1 is this, and 1 to 2 is this, guys, and we will take intersection of these two. Okay, clearly here you can see x minus 2 not equal to minus 2 is also we need to take care of. Okay, so if you take the intersection, so minus 2 to minus 1 common area is this only, guys. Okay, so minus 2 to minus 1 would be the answer of the second part. So the final answer would be the union of first and the second. Okay, so guys, the first part and the second part we will take union. So minus 2 to minus 1, minus infinity to minus 2 we will take union. Just a minute, guys. So we will take the union of first and the second case, guys. Okay, so the second case that we obtained was minus 2 to minus 1, that we have plotted here. This is the second case. Then we will take union with first. First case was minus infinity to minus 3. Union 2 to infinity, guys. So this we will take union. So taking union first and second. Okay, minus infinity to minus 3, union 2 to infinity. We will get this minus infinity to minus 3, then which is this, minus 2 to minus 1, which is this, then 2 to infinity, which is this. So all the union of all the three cases comprises the final solution, guys. Okay, which is the final answer.